So these are the inputs, whatever is required as a global stiffness matrix, and this will prepare a global K. Okay. Okay. So now to solve a problem for a debugging purpose, what I do, this will return K. This will return element I create this as a global, so that will avoid the problem. Okay, so once I create a global, I don't need to pass on this, so it is easier for debugging purpose. Later on you can change it, and I say return element. Okay, so this is what I'm going to have, element. So instead of now global K, I will call this matrix as a input. Okay, input. So it might confuse with JavaScript function. So I call that as the input one. Okay, better way. So it won't get confused with the inbuilt JavaScript function input. Okay. So these are the things which we call as input, where we are going to just provide the input, and that is what gives me a element. Okay. So I could run this program and get the value of that particular element. Okay. So let's do it, whether we are getting a correct thing or not. So this is I 0, 1, 2, 3, 4, 5, 6, 7. This is correct. I'm creating a empty 2D matrix, that is fine. Okay. So just I hit save, and I'll just open this file. Okay, so I press F12 key. Now I can start input 1. Okay, so number of nodes will be 3. Number of elements will be also 3. Okay, we could have 2 elements also. That therefore we are actually providing separately number of nodes and number of elements. Okay. So now it is asking me area of first element. So 100. Modulus of roughly 2e5. Start node number is 0. End node number is 1. I require x1 0. I require y1, that is also 0. x2 1000. y2 0. Okay. So it is asking now second element. So area is 100. Modulus of 2e5. N1 is now 1, N2 is 2, x1 of that is 1000, comma 0, sorry 1000 only, not comma, y1 0, x2 1000, y2 1000. Now this is the third one, area 100, E2 E5, N1 0, N2 2, x1 0, y1 0, 1000 and 1000. Okay, so I do got the array, so I could verify whether I am getting a correct one or not. So 0 1 1 2 0 2 and all other coordinates, each and everything I am getting settled in this input 1. Okay, so I may have copied this, but no, this is element basically. So I did not copy, I did not put it like this way. Okay, so if I could store it in a key, okay, so array 8 by 8, so I did not store in element. So now I'll have the element which value I'll be giving. So instead of writing input, I should have written element is equal to input 1. So if I write in this way, automatically I will get this element as array. Okay, so but now I did it in some different way. So I got the element which is containing the given what you say array which already I have. Okay, so now I will prepare a global stiffness matrix from the what you say element matrix. So I will create now function global k. Okay, so now in global k we are going to prepare a global stiffness matrix, and we require a k matrix to be created. Okay, so I could say k is equal to array of, so array of node number n plus 1 dot fill, I want to fill 0 dot map array, and that will be also of n plus 1 dot fill 0. Okay, so we can execute this. So we'll try to copy this, and we go to Chrome browser and we'll paste it. Okay, so now we get the array of all zeros, which is a global stiffness matrix which we require. Okay, so now my degrees of freedom is multiplied by 2. So therefore I don't need 3 by 3. Actually I will be needing a 6 by 6 global stiffness matrix. So I need to multiply 2 into this. Okay, because each node now will be having a 2 degrees of freedom. Therefore this will be 2 into n plus 1. This is what I am going to require. Okay, so I will get a 6 by 6 matrix in this way. Okay, इस जर करायचं तर U टाइप करा बरं. You can type U. नसेल कळलं तर प्रश्न विचारा. Okay. So now, one of the important thing you have to understand. So, how the degrees of freedom are created? So, if this is a node 3 and this is a node 4, okay, so you have to multiply this by 2. So, therefore, vertical will be Q6 and horizontal will be Q5. Now you have to multiply this 4, therefore vertical will be Q8 and horizontal will be Q7. So in this way, each element, each node will be having a degrees of freedom. So how do you create it? So basically multiply the node number, okay, that will be vertical 1 displacement, and a horizontal 1. To get it horizontal 1, you have to subtract the 1 from it. Okay. So that is why we are going to require here in this case at which location the matrix should be added. Okay. Now I require that full matrix. So right now I don't have. So we will multiply manually. Just a moment. I need to set up a device. So we have K as A by LE, L M minus L minus M, and we have L M minus L minus M. Okay, so now I need to go for the multiplication. So AE by LE, so it will be 4 by 4, L square LM minus L minus LM. Then I have LM M square minus LM minus M square, L square. Then minus L square, so it is a symmetric, so I could write like this, L square LM M square. Okay. So this matrix I have to remember because I need to calculate cos and sine of each element. Okay, and then we have to prepare this one. And now how this will be there? So let us say if I have a 3 and 4, okay, so I have to multiply by 2, so I get 5, 6, okay, and if I have a 4, I will get a 7, 8, okay. So my column and row heading will be 5, 6, 7, 8, 5, 6, 7, 8. So at this location, these elements should be added. That I have to remember. Okay. So let us consider if this is the element which I have to add. So I have to remember this will be 6, comma 6. Okay. Or if this is I have to add, then it will be a 7, comma 6. So in this way, I have to create all the elements that I have to remember it. Okay. So it's a pain creating that, or else you could directly multiply L and M. You could create a multiplication of matrices program, but again the row and column heading will be troubling, so you have to add manually. Okay, so you could create it dynamically, assigning the rows and column, but again it requires a high skill level of programming. So I am not also using object oriented programming language. If you use the object oriented, you could create a modulus of velocity, start node, end node. In this way you could always create it. Later on I will show you. I have wrote a program for the pipe element. So you will understand that using those object oriented concept, you could create a lot of easy stuff. So with limited programming languages knowledge, it is very, very difficult to do it. So I may show you the program. So you could create a such kind of framework with namespace and class. So each one could have a point. So this is related to point. Then you could have a line function, how the line works, line to draw it. And this is basically a pipe element, which is a circular element which I am trying to create it. And it will be having its start point, an angle, whether it is clockwise drawn, anti-clockwise drawn. Okay, you could have all the draw related stuff. Then you could create a node. Okay, so it will be having some nodes also. So node number you can create it. What are the various node number you can pass on to this, and we'll be having a draw of element. Then we could create a mesh that how many number of divisions we want. So it's a automatic meshing tool which we have created. And you could create a global stiffness matrix, and we have the how many number of nodes are there. These are related to temperature, so you can apply the temperature boundary condition, density, and various mass properties also. Okay, you apply the temperature, apply the mass. You could create a mesh, and for creating a mesh, you call the function create nodes and the create element, which is be later on created. So this will be creating a nodes. That how the nodes will be created, and these are the elements. So this basically enables this will create a node container, and from that node container it will start creating a 1D element. You could create a various type of element. So we have a arc element, pipe element, 1D element. So you could call how many which element you would like to create. So you call that particular function, it will start creating a one-dimensional element. Okay. And of course, we can create a temperature force, we can create a mass matrix in this way. So this is basically a object-oriented programming language where we create a classes. Okay. So You could see this is a class. Okay, so how we are meshing the 1D arc. So this is related to mesh, and you could create a node, create element. So it's a huge program which I have wrote it. So when you write a object-oriented programming program, you do it becomes a lot easier to create a code. Okay, so presently it is a very challenging job without using object-oriented principle to write the program on the truss. Okay, so it's a huge line program, maybe of more than 20,000 lines. Okay, so this is just one framework, and there are several such kinds of framework which I have created. Okay, so so basically I work with Vinod Apotkar. He is a consultant from the ISRO, and we create the basically APA package for the field software. Okay, so now we have this array we have created. Now we require element. So global K will require element matrix. Okay. So for I is equal to 0, I less than is equal to now the number of nodes are n. So I have to multiply 2 because number of degrees of freedom are not multiplied by 2. So 2 into n plus 1. Okay, and then I have I plus plus. Okay, so now let's do it. So first thing is getting a row and column heading. That is a challenge. Okay, so I'll get var r1. Okay, so I write r2 basically row 2. Okay, so row 2 will be, so I need to now get it element. So it will be ith element, and now which thing I want for the, I want a number of nodes, number of n node. Sorry, this n I want. This is the node number which I want. So it is stored in 2. Okay, so I'll use 2. So I got n1 into 2. So this will be the row number 2. Okay, now I could create a var r1 which will be equal to r2 minus 1. So this is the row number 1 of that particular element. Similarly, I will create a r4, that is the row number 4, will be equal to element ith element, and I need to find which property now? I need to find third one. Okay, so in the third one it is n2, and it is to be multiplied by 2. Okay, and I get the var r3, row number 3 will be r4 minus 1. Okay, so if you have understood this concept, how I am getting a row, you can type y. There is my mobile. हा कन्सेप्ट जर कळला असेल तर यू कॅन टाइप वाय. नाही तर विचारा क्वेश्चन. मी हे लॉजिक इथे एक्सप्लेन केलं की हाऊ आय गेट द रो नंबर फ्रॉम हियर. So degrees of freedom are the row numbers here. Okay, so I could say this is R6 and this is R5. I could say this is R8 and this is R7. So multiply 2 and subtract 2. So if you have understood this, you can type Y, or else you can ask the question. Okay. Now I could create a combination of that. So now I have the global key which is created is total degree of freedom. Okay. So now I am ready to replace that value. Okay. So I'll have first R1, okay, and R1, okay, which will be equal to. So if I see I have wrote this thing, it is equal to L square. So I don't have a L. So I need to calculate L first. So for that, length of element is also required. So I'll calculate LE. Okay, later on separately LE you can also store in that particular array. Okay, so that could be part of 8, and also ln cos could be also required, because later on we require to calculate stress where the B matrix is required, which involves the length as well as which involves the L and M, that is cos and sin. Okay, so instead of that, now what I will do, I will add in the element itself. So now I will create a I. So this is, we are working with the ith element. Okay, so I will add 8. 8 will be length of an element, okay, which I am going to calculate. Okay, so I could write a comment. I may forget it what I am trying to do, so I can write this is my length which I am going to add it at the 8th location, and for that I require x1 x2. So x1 is in 4, y1 is in 5, and x2 is in 6, and y2 is in 7. So it is 4 minus 6. Okay, so I could write math dot POW. Okay, so I need to write square again, math dot POW. Okay, and of delta x. So that is element, I element, and which property? Fourth one. Fourth is x1 minus element, which element? Ith element, and which property now? It is sixth one. Okay, comma 2. So this is what I am going to get it as a square, plus I need to add delta y square. So I just copy paste this, so I don't need to type it again. I paste it. So this is my delta y square. So for y I need to add 5 here and 7 here. Okay, and I need to write comma 0.5. So it will be under root. Okay, so in this way I am getting this all this stuff. Okay, so this is basically under root of delta x square plus delta y square, and this is for the under root. So in this way I got the length. Okay, once I got the length, now let's calculate L. Okay, so I will again store L in 9th element. So I will write that I am storing a L. This is my comment, I, and I am going to store in the 9th element, which will be equal to, okay, x2 minus x1. So already I have written this is my x2, and this is my x1, and divided by, now 8th element is my length, so I could divide with the length. So in this way, my ninth element will be created. Now I want M. So I could write, copy paste this. This will be 7. This will be 5. And this will be 8. So in this way I got the M also. Okay. So now I could create and go and create the all the stuff. So I also require A into E. Okay. So to shorten this, I will create a var A is equal to element. So which is the area? Area is 0. I 0. So it will be a lot easier for me to understand what I am doing. Var E is equal to, now what is E? E is 1. Okay. So element I, and it is 1. Then I could write var, I could also say element, and the length is now 8th one. I, and it takes property, so I got the length. So now instead of using this big array, I can use A, E and LE. So I could write A into E divided by LE. So that's the better way. Okay. And into. So this is 1 1. So if I go here, so my 1 1 is this one, that is L square. Okay. So I have to create a L square here. So now L square is my, okay, I could also write better way, var L, and L is what? This element. And I could write M also. So instead of using this array, I will be using this labels, but it is stored. Okay. So into L square. So L square I write L into L instead of that math.pow. Okay. So this is my first element R1 into this one. Now I have to go with the column number 2. So column number 2 is R2. Okay. So column number 2 is my L into M. Okay. So this is equal to, so I just copy this, paste it. This will be L into M. Now one important thing you have to remember, you could immediately go for the symmetry operation. Okay. So you don't have to write the full operation as it is. So instead of this, I could put R2 here and R1 here. So they will be same because it is symmetric in nature. So R1 R2 will be equal to R2 R1. So this will help you. So what work remains is that you need to create this upper half, and automatically the lower half will be automatically created because it is symmetric. Okay. So we'll be creating only upper half, and I use the symmetry operation that I just change the interchange the rows and columns, and automatically it creates the other one. So I don't have to look after that. Okay. Or else I could say this equal to this also, that will also do. Now K R1 R2 I have created. Okay. So presently I just comment this because I want to create upper, and later on I will unlight it. So I should not make a mistake. So I created R1 R2. I go for the R3. Okay. And what is R3 now? R3 is minus L square. So I just put a minus sign here. Okay, then I can copy this and paste it here, and I could change now R3, R1, that will be also same. The next is R1, R4. R1, R4 is minus LM, so I just put it M. And I can copy this and paste it here. I could say R4, R1 and this one. So in this way you could create a full matrix and where it will be added. Okay, it is going to take some time to do it. So next time when you come back, I'll put all the stuff. Okay, presently only first row has been added. Now I have to add second row, I have to add third row, and I have to add the fourth row. So in this way I'll make this sure. So I hope you have understood this logic, how we are going ahead. And next time we will see how we can apply the, see, once you prepare the global stiffness matrix, it's a hardly anything else. The next program is the apply Gauss elimination method, which already you have written, because it is KQ equal to F. Now you can pass on this K, Q and F, it will solve it. Okay, so the challenge is to prepare a global stiffness matrix. That's it. Once you are able to prepare it, K, Q, F, you pass on to the Gauss elimination method and it will solve you for you. Okay, so if you have understood this up to this, you can type U, and next time we will continue. Okay, now you can start living. Thank you.